All right, hi. We are going to be looking at the notes for the velocity versus time graphs. So the question that's guiding um, our notes today is how do you get displacement from a velocity versus time graph? So displacement is how far you are from where you started or in kind of sort of the distance you traveled, right? So if you have a velocity versus time graph, that's of course showing you how fast you're going and in what direction. But how do you get how far you went from that? Okay, so let's remember back to right the equation. So algebraically, displacement is equal to the velocity times by the time, right? That's just you're going 60 miles an hour for 2 hours. Well, that means you went 120 miles, right? So that's nothing that we're unfamiliar with here. This equation. So if you have a velocity versus time graph, right? Velocity times by time, velocity times by time. That's going to be an area, right? Because velocity is going to be more or less the height, and time is going to be the base, right? So that's going to be velocity times by time. That's what we call the area underneath the curve. So when we talk about the area underneath the curve, we're talking about like a geometric area, just like you're familiar with from geometry. And when we say curve, we just mean whatever the line is made by the graph. So it doesn't actually have to be curved. It can be straight or linear or right. In fact, you're actually never going to have a velocity versus time graph that's actually curved. This is just a mathematical expression so that because that encompasses like um, any graph. So it's a fairly common thing from like calculus. So anyway, the when we say the word curve, we just mean whatever the line is. And then it says, AKA between the line and the axis. Well, the reason it's phrased like that is because if this is my line and this is my axis, it's the area that's sandwiched in between those two. If I was to have a negative velocity, so it's like down here somewhere, then it would be between that and the axis. So it's really what it really means is not the area underneath the curve, but the area between the line and the axis. So displacement from 1 to 4 seconds. So let's say we ignore the very first second. We just want to know like how far does it go from 1 to 4 seconds, going 6 meters per second. Now this isn't a terribly difficult problem. You could probably have figured it out without doing this, but it is helpful if the object starts changing directions and stuff. The displacement from 1 to 4 seconds can be found by finding the area of the shaded region. So here's my shaded region, this red shaded region here. The area, it's a rectangle, right? So you can just do base times height. So the area is equal to base times height. The base is 3 seconds, right? 1, 2, 3. And the height is 6 seconds, right? All the way up to 6. So 3 times 6 is going to give you 18 meters, right? So, so there are your notes on the velocity versus time graph. Now to move on to the example problem. So here we have our example problem. It's I'll label it here, but this is a velocity versus time graph versus time. And so, right, the first question it asks is, what is the displacement from 0 to 4 seconds? So to figure out the displacement from 0 to 4 seconds, we're just going to shade in the region between the line, which is right here, and the axis, which is right there. So that's going to be this area right here. So now we just need to find that area. So the area from 0 to 4 seconds, right, would just be base times my height. So the base is going to be 4 seconds because 2 4 seconds times by the height, which is right, is going to be whatever the velocity is here, which is -3 meters per second. Remember, displacement does have a negative sign, so you do have to take into account the fact that it's a -3. So that's going to give us a displacement. Remember, displacement is delta x of 4 times by -3, which is -12 meters. So now to do the displacement The next problem, right? What is the displacement from 4 to 10 seconds? So that's looking at this area spot right here. So we're just gonna shade that region in now. The problem ever asks you to like show the displacement on a velocity versus time graph, this is how you show the displacement on a velocity versus time graph. You just shade it in. So that problem might show up later. So now we just have to do, right, find our area. That is going to be base, which is 2, 4, 6, 6 seconds, times by the height, which is just 1 meter per second. Uh, it is kind of cool. You can check your units here. You have a seconds, which is in the numerators. You also have a second, which is in the denominator, because it's right meters per second. So that seconds is going to cancel with that seconds, right? Leaving you just meters as your units. So it's sometimes nice to be able to double check that. That means your displacement, right? Because your displacement is your area, is just 6 times by 1, which is 6 meters, and that's positive because we were traveling in the positive direction. So then lastly, right, what is the total displacement? So your total displacement, remember delta x is your displacement, right? Total, delta x subscript total there, is going to just be the sum of those two. So that's going to just be negative 12 meters. So we went 12 meters in the negative direction plus positive 6 meters because we went 6 meters in the positive direction. And so that's going to be, right, negative 12 plus 6 is just going to give you negative 6 meters as your total displacement. And there you go. So those are all the example problems for the velocity versus time graph or velocity versus time graph notes. Thanks for watching. Bye.